Hello and welcome to the course of Computer Network. Today we are going to study one of our reliable protocol which is completely based on the concept of pipelining with name Go Back N. But before going into the detail of Go Back N protocol, let me just brief you the last lecture once again. In the last lecture we studied about stop and wait protocol, which is again a reliable protocol, but channel utilization of that particular protocol is very less. So this is the reason why we have developed a new protocol with the concept of pipelining, which increases the utilization of a particular channel. If you go back and look at the stop and wait protocol, in which sender has to wait for the acknowledgement before sending the next packet. So after sending a packet, sender comes in an idle condition where it does nothing, and that is the wastage of time by the sender. But sender is compiled to do that. It has nothing to do during that time. It just have to wait for the acknowledgement, and once acknowledgement is there at the sending side, then only sender can send the next packet. So this is the reason why channel utilization by stop and wait protocol is very less. So today we'll see the concept of pipeline protocol in our first protocol with the pipeline concept Go Back In. So here we see the concept of pipelining. Uh, as you see in this left diagram, stop and wait protocol in operation, you can see this sender is sending the data and it is waiting for the acknowledgement from the receiving side. Once acknowledgement is at the sending side, then only sending side can send the next packet, and the utilization of this particular protocol is very less. And if you see a new protocol with the concept of pipelined protocol in operation, you can see sender is keep on sending the packets without waiting for the acknowledgement. So this is the concept of pipelining, in which sender can send a amount of packet without waiting for the acknowledgement to the receiving side. And once that amount of or number of packets are sent from the sending side, then sender can wait for the acknowledgement. Meanwhile, if sender receives the acknowledgement of some packets, again it can send the packets. So that is how our pipeline concept works. You can see in this slide, and you can understand the utilization of pipeline protocol uh, is increased. If you use a pipeline protocol, channel utilization is increased. Here you can see uh, this is the time required by the sending side to transmit one packet into the link. Here you can see T is equals to L by R, which is transmission time, L by R, where L are the number of bits present in the packet and R is the transmission rate. So with the case of pipelined concept, you can see sender is transmitting the first packet, and immediately it is not waiting for the acknowledgement. It is sending the next packet, and after sending the next packet, it is again sending third packet as well. But if you see the case of stop and wait protocol, after sending a single packet, this particular sender is waiting for the acknowledgement. Once acknowledgement is here, then this particular sender sends the second packet. But here you can see with the case of pipelining, sender is sending packets consecutively without waiting for the acknowledgement. So here you can see the difference in the utilization. Initially it was L by R divided by RTT, round trip time, plus L by R, the complete time, and it was about 0.00027. Here you can see the difference. This time, in the same time, sender is sending three packets. That means it is transmitting three packets into the link. So you can see the difference. 3 packet pipelining increases utilization by a factor of 3, which you can see. So that is why pipelining protocols are more useful, and the utilization of pipelining protocols are uh, more than a stop and wait protocol. So here we see this slide shows us the difference between go back N and selective repeat. Both the protocols are based on the pipeline concept, but we'll see this particular slide later once we are done with the protocols. So here we see uh, our first protocol with the pipelined concept. And whenever you use a pipeline concept, new thing comes uh, into play, and that thing is window size. Go back N has a window size available at the sending side. Now a question must be arising in your mind that what is that window and what is that window size. This window size means, let's see uh, at this particular thing. This is the window size which has n packets. That means this particular window has n packets. This window size means sending side can send n number of packets from the sending side to the receiving side without waiting for the acknowledgement. It means sending side can send n number of packets which are available inside its window without waiting for the acknowledgement from the receiving side. Once sending side is done with this all packets which are present in this window, then it may have to wait for the acknowledgement. But initially this particular sending side can send n number of packets which are available in this particular window to the receiving side, which increases the utilization of a particular channel. So that is how it's done. So let's understand the concept of go back N with the help of this sending side packets. These sending side packets are divided into 4 categories, which you can see. These green packets are those packets which are sent and acknowledged as well. You can see over here, already acknowledged. These packets are sent and acknowledged. Now this window starts, and the first packet of this particular window is called send base, and the last packet of this particular category, yellow packets which are residing inside this window, uh, is this. And these yellow category is these packets are sent from the sending side to the receiving side, but these packets are not yet acknowledged. In this same window, this blue category are the packets which can be sent from the sending side to the receiving side, but they are still inside the window. They are not sent yet, but these packets can be sent. And this first blue packet is called next sequence number, which means after this last yellow packet, this yellow packet which has already sent from the sending side, this first packet which is still inside this window is called next sequence number, which is to be sent from the sending side to the receiving side. And these white packets which are not inside this particular window are the packets which cannot be sent from the sending side till the time they all come inside this window. Now the question arises is how these packets will come inside this window. So whenever you send a packet from the sending side, whenever you send a packet from the sending side, now this ascending side is in a state of waiting for the acknowledgement. Once these packets are acknowledged, this particular window will slides towards its left or ours right, and these not usable packets will start coming inside these windows. And once they are inside the window, they are also eligible to be sent from sending side to the receiving side. So this particular window slides the moment these yellow packets are getting acknowledged. This particular window will start sliding, and these yellow packets will become green packets. Those are in a category of already added, which means these packets are sent and acknowledged as well. One thing which is mentioned, important thing which is mentioned in this particular slide is cumulative acknowledgement. That we will understand this particular concept of cumulative acknowledgement once we will see this particular protocol in action, because uh, for understanding this particular concept, you need to understand the receiving side as well of the go back end. And till now, we have understood the sending side of the go back end protocol, which is based on the pipeline concept. And pipeline concept is nothing but sending side can send n number of packets to the receiving side without waiting for the acknowledgement, and those packets are those packets are inside a window. If your window size is n, then your sending side can send n number of packets which are available in that particular window. And this particular uh, sending side has four categories, as I have already told you, that this green category are those packets which are sent and acknowledged. And now this yellow category inside this window is these are the packets which are sent but yet to be acknowledged. These blue packets are those packets which are still inside this window. These packets can be sent, but still they are inside the window. And these white packets are unusable packets which cannot be sent until these packets come inside this window. And how will they come inside this window? When this particular window will slide. And when this particular window will slide, when these yellow packets will start getting their acknowledgements. Once they get the acknowledgement, these yellow packets will come under the category of this green packets category, which means sent and acknowledged. So that is how this go back and sending side is designed. So we will shortly see the FSM of this particular sending side of go back n and the receiving side of go back n. Will understand the concept of go back n with the help of FSM in our next slide. So here you see the go back and sender FSM, finite state machine, in which you will find only one state. And we'll start with this is reliable data transfer send method. And this portion is in a loop where the condition is if next sequence number is less than base plus n, which means this is your sending side. And you can see this next sequence number should be less than base plus n, which means your packet which is to be sent should be inside this particular window. Then only sending side can send that particular packet. And this base plus n would be base would be this number and n would be the packet size. That means this FSM wants to say that the next sequence number shouldn't be outside of this particular window. If base plus n is greater than this next sequence number, then it would fall outside this window. Base plus n would be this packet, and if next sequence number is less than this particular packet, then that particular packet falls inside this window, then only sender is allowed to send that particular packet. And after, once this condition is satisfied, then uh, you can make a packet and you can send it through unreliable data transfer send method. Then you can check again a condition which is base equals next sequence number. uh, that is the case when this window is just created and all the packets are still inside this particular window. At that moment, this send base packet, this packet would be the next sequence number packet, because first packet is yet to be sent from the sending side to the receiving side. It is that scenario which you need to assume when send base is equals to next sequence number. That means when you just created this window and all the packets are still residing in this window which can be sent from the sending side to the receiving side, but none of them is sent from the sending side to the receiving side. In that scenario, send base packet would be next sequence number. These both the packets will be at this position. So if that is the condition, then only you have to start the timer. Once you start the timer, then you will increase the next sequence number, and again you will check next sequence number. If this particular sequence number is still less than base plus n, that means if that particular next sequence number is still inside this particular window, you can send that particular packet. Otherwise you have to refuse the data, you cannot send the data. So I hope you understand this portion. Now second portion is this of the sending side. If timeout happens at the sending side, then you will start the timer again and you will send the base packet this time. Base packet means this packet again. If timer started at this particular packet and this timer of this particular packet times out, then you have to start sending all the packets from the base packet, because uh, at the receiving side window size is not available. Receiving side is allowed to accept or receive the packets in an ordered way. Receiving side cannot receive out of order data. That we will discuss once we will see this particular protocol in action, the receiving side, and then this thing will be more clearer to you. Once you are done sending retransmitting the packet from the sending side to the receiving side, you will keep on transmitting all the packets again which are residing inside this window from send base point. From this particular point, this particular packet onwards, you have to send all the packets again if timeout occurs. And finally you need to stop at next sequence number -1, which means you need to send the packets till this particular point, and then the same condition, same thing starts this one. Now we'll try to understand this portion of the code. uh, Once your sending side receives some data, sending side always receives acknowledgements of the send data. So if your acknowledgement is not corrupted, then what happens, what all you need to do is you need to put uh, the acknowledgement number +1 inside the base. Let's understand this thing with this particular sending side diagram. Once you receive the acknowledgement of this particular packet, then what all you need to do is you need to uh, change this base to the next packet. And how will you change it? You can see over here, get acknowledgement number from the packet which you have received, from the acknowledgement which you have received, +1. So that means if you have received the acknowledgement of this particular packet, then you will extract the acknowledgement number of this particular packet and you will add 1 in that particular number, then it will become this particular packet. So now base has changed, base has changed to to the second packet inside this particular window. So this send base would be this now. Once this first packet receives the acknowledgement or got acknowledged. So that is how it's done. Once it is done, then again, if base is equals next sequence number, which you see in this particular code, then what you will do, you will stop the timer, or else you will start the timer again. So that is how your sending side of go back n works. It's a brief introduction of the sending side of go back n. Here you see the receiver of go back n protocol, and let's try to understand this particular code. Once your receiver receives a packet which is not corrupted, you can see over here, and has a sequence number which is expected by this particular waiting state. Because as I told you earlier that in go back n, at the receiving side there's no window size available. The window size is 1 at the receiving side. That you will understand when we'll see this particular protocol in action. But here you need to understand that once your receiving side receives the data, that data should be in order, otherwise receiving side will never receive the data, because at the receiving side window size is 1. So once your data is received by the receiving side which is not corrupted, and it is the same data which you are expecting, then this receiving side will extract the data and deliver that data to its upper layer, and it will create a acknowledgement for that particular data and send that acknowledgement to the sending side again. So that is how its receiver works of go back n protocol. And here you see the important point about go back n's receiver is always send ACK for correctly received packet with highest in order sequence. This thing is telling us about the cumulative acknowledgement, and that again we will see shortly, the concept of cumulative acknowledgement. And second important point of this particular slide is out of order packets, which I've already told you that it discards out of order packets, because at the receiving side there's no receiving buffer available, there's no window size available. One packet which is expected by the receiver has to come, then only that particular packet is received, otherwise that particular packet is discarded at the receiving side. If that particular packet should be in sequence, which means receiver go back n's receiver always receives the data in ordered way. Now you will understand this go back n protocol very clearly, because now you will see this particular protocol in action. As you can see, we have sending side and we have receiving side. We have window size available at the sending side. You can see n is equals to 4 over here. That means 1 2 3 4. In this particular window we can have 4 packets which can be sent without waiting for the acknowledgement from the sending side to the receiving side. And you can also see the sequence numbers have increased. In stop and wait protocol we used only 2 sequence numbers, 0 and 1, but here in go back n you can see you can increase the sequence number as much as you can, but there is a restriction for that we will discuss later. But before that you need to understand this particular protocol in action, that we have got 0 to 8, that means 9 sequence numbers, and at the sending side we have got window size 4 available. So let's play this particular protocol, send packet 0. So from this particular window you can send all these packets from 0 to 3. And at the receiving side you will never find a window available. So receiving side has window size 1. It receives only one single data at a time, which is expected at the receiving side. So initially 0 is expected at the receiving side. If you send 0, it will receive by the receiving side, and it will send the acknowledgement of packet number 0. Then from this window you will send packet number 1, packet number 2, packet number 3, because from the sending side you can keep on sending packets sequentially in a continuous way to the receiving side, because window size is available at the sending side. And let's check what happens at the receiving side. 0 is there, 1 is there, but 2 is not there. And now this receiver side will get stuck, and it will uh, receive 2, then only it will receive the third packet, otherwise it will not move further. It will stuck over here. As you can see, packet number 2 is lost in between. But from the sending side you have already sent packet number 3. It is received by the receiver, but it is discarded by the receiver because there's no window size available at the receiving side. Receiver side can receive the data in an ordered way, so it will receive packet number 2 only, then only it can move further. So here you can see, after sending these 4 packets from 0 to 3, 0, 1, 2, 3 packets, this particular sending side will in a waiting state. This particular sender can send these 4 packets without waiting for the acknowledgement. And you can see over here this sending side is in a waiting state now. Now you can see receiving side has already sent acknowledgement of packet number 0 and packet number 1. Once these two acknowledgements are received by the sending side, once these two packets are acknowledged by the receiving side, this window will slide, and these two more packets will come inside the window. As you can see, once you receive the acknowledgement of packet number 0, it is shifted once, and packet number sequence number 4 comes inside this particular window. Once this sending side receives acknowledgement number 1 of packet number 1, this window again shifts towards its right, and this time packet number 5 also comes inside this particular window. Now you can see these 3 categories of this particular window. These 2 packets are already sent and acknowledged. These packets can be sent, and these are not usable packets, no usable packets which cannot be sent till the time this window shifts towards its right. So here you have seen what happens at the sending side. Now it is still in the waiting state, but once this particular window slides towards its right, this particular sending side can send packet number 4 and 5 as well, because these 2 packets are now inside this particular window. And once these packets are done, uh, but you can see at the receiving side is still expecting packet number 2. So receiving side will receive packet number 4, but it will discard it, and it will retransmit the acknowledgement of uh, packet number 1 to make the sender understand that only packet number 1 is received. After that I haven't received anything, because I'm expecting 2 and I didn't get packet number 2. So it will discard packet number 4, it will discard packet number 5, and it will keep on sending the last correctly received packet, which is packet number 1. So it will keep on sending the acknowledgement of last correctly received packet, which is acknowledgement number 1, which you can see. And then what happens, all of a sudden timer time out occurs at this particular point, and then this particular sending side will start sending the packets from packet number 2 again, because the sending side is receiving the packets of acknowledgement of packet number 1. So it will understand that 2 is not yet received by the receiver, and sending side has to send all the packets all over again, 2, 3, 4, 5, which this particular side has already sent. You can see 2 is lost, 3 is received, 4 is received, 5 is received, but these are discarded from the receiver side because receiver is expecting packet number 0 over here. Once it receives timeout happens at the sending side, it will start sending the packets all over again, and fortunately these packets are received properly at this time. So here you can see that is how go back N protocol works. The main thing which you need to understand in go back N protocol is sending side is available with the window size. That means sending side can keep on sending packets which are available inside its window to the receiving side without waiting for the acknowledgement, but due to unavailability of receiving side window, receiver can receive the data in a ordered way. Receiver cannot receive the data in unordered way. It cannot receive out of order data. So that is a very good thing about this protocol, that at the receiving side data will always be received in order way. Now we need to understand one more thing over here which we skipped in our last slide. It's all about cumulative acknowledgement. So we need to understand the concept of cumulative acknowledgement as well. Let's take an example in this slide only, that once this packet number 0 is received by the receiver and it sends its acknowledgement to the sending side. Let's assume this particular acknowledgement is not received by the sending side. Then what happens? Packet number 1 comes to the receiving side because it's in the window of this particular sending side, so sender can send this particular packet. This is also received by the receiver because receiver is expecting packet number 1 at the receiving side, but you know acknowledgement of packet number 0 is lost somewhere, and packet number 1 is also received by the receiver. Then receiver will try to send acknowledgement of packet number 1 to the sending side in this case. And if this particular acknowledgement is received by the sending side, what I mean to say is, in this particular window, if packet number 1 or packet number 2 got an acknowledgement from the receiving side, and sending side didn't get the acknowledgement of packet number 0 and 1, and it receives directly the uh, acknowledgement of packet number 2, then that acknowledgement number will be considered as a cumulative acknowledgement for all the packets before that particular packet. Which means if sending side receives the acknowledgement of packet number 2 without receiving the acknowledgement of packet number 0 and 1, it will be considered at the sending side that all the packets before 2, like 0 and 1, are also received by the receiver. Because sender knows about the quality of receiver, receiving side will never receive out of order data. And if sending side receives the acknowledgement of packet number 2 without receiving the acknowledgement of packet number 0 and 1, sending side will not be bothered about packet number 0 and packet number 1. It will be satisfied with this cumulative acknowledgement of packet number 2, and this window will slide towards its right, and next 3 packets 4, 5, 6 will come under this particular window. So the next new window would be 3, 4, 5, 6, because till 2 packets are sent and acknowledged. So this is the concept of cumulative acknowledgement. I hope you have understood the concept of go back n. But before closing this particular lecture, I'll show you an animation of go back n through which you can understand this particular go back n protocol with the concept of pipelining more clearly. So we'll see it in the next slide. So here is the animation which you can see on your screens. Uh, for this is for go back n, and you can see go back n. You have few tabs over here which you can control from your end, and you can start this particular animation from this particular tab. And here you have these two. This is the sending side, and this is the receiving side which we have. And here you see the window, and this window size is 1, 2, 3, 4, 5. So window size is 5 available over here, which you can see with this tab as well. Window size 5, which you can increase and decrease by increasing and decreasing this particular thing. And here you can see white, no data received yet; blue, data buffered, ready to send, delivered or sent but no ACK received yet; green, which you will see shortly, those are the acknowledgements; yellow, transmission confirmed; blue, data has been delivered to the upper next layer. So we'll start this particular animation, and here, and now you can see timer has started the very first packet. Now once it receives the acknowledgement, it will shifts right. Once this is received, you can see over here, and after receiving the acknowledgements, this particular window is sliding towards its right. And what you can do, you can delete this particular packet as well. That let's I have removed these packets. These packets now will not be received, because receiving side will receive the packets only in an ordered way, as you know. And you must have seen some operation over here that it has sent receiver will send the acknowledgement of last correctly received packet. So I'll remove this packet again, and you can remove, and this packet will be received, but it will be discarded from the receiving side, because it receives the data in an ordered way only. So that is how it runs. And you can play with this particular animation at your place. You can, if you want, you can note down the website where you will find it, and you can play it with. You can increase and decrease the timeout. You can increase the size of window. You can increase the delay, and you can delete the acknowledgement as well from here. Now you will see the I'll show you the funda of cumulative acknowledgement. I'll remove this one, I'll remove this one, I'll remove this one, I'll remove this one as well. Oh no, but once you can see, you just saw this cumulative acknowledgement received by the sending side, and sending side understands that if receiver has sent me the acknowledgement of that particular packet, so that means all the packets must have received before that particular packet by the receiving side. So that is the concept of cumulative acknowledgements. So in go back n, you have two things which you need to remember. First thing is, at the receiving side, window size is not available, and window size side receives data in an ordered way. It does not receive out of order data. Second thing, because of not availability of receiving window at the receiving side, sender can satisfy with the cumulative acknowledgement. So it's not like receiver has to send all the acknowledgements, and sender has to receive all the acknowledgements. This particular protocol can work with the help of cumulative acknowledgement. So I hope go back end protocol is clear to you now. If you have any problem, you can ask me in the comments. Thank you very much. See you in the next lecture, and in the next lecture we'll study again reliable protocol which is based on the pipelining concept with the name selective repeat, and you can see selective repeat. So if you click at this particular point, you can play with the animation of selective repeat, but we'll see that particular lecture uh, in our next video lecture. We'll discuss selective repeat in our next particular lecture. uh, till then, be safe at your homes. Thank you very much.